Hi guys, today we're going to talk about what it means to solve a quadratic equation by taking square roots. Before we start talking about actually solving the quadratic equations, we want to look at what it actually means to solve a quadratic equation. So if we look over what we've already studied so far, first semester with quadratic equations, notice that so far we have talked about their shape. We talked about how we can look at and say if it's ax squared plus bx plus c, if a is greater than 0, so a is positive, then we say it wants to open up to look like this, whereas a is negative, then it's going to open down like this. Either way, it's going to be the shape of that parabola, just determining is it opening up or is it opening down. We also have talked about the axis of symmetry. We talked about how that is the imaginary line that cuts our parabola in half. We said we could find that by using the equation x equals negative b over 2a. So far we have also talked about finding the vertex. So either that maximum point or that minimum point, depending on if it's opening up or if it's opening down, being either a minimum or a maximum. Remember, the vertex is a point, so it is listed as x comma y, and we find the x value by using the same equation as we use for the axis of symmetry, x equals negative b over 2a. We then find the y value of our vertex by taking that x value we've already found by using that formula and plugging it in to the quadratic equation we're given. The other thing we talked about already is how to find a y-intercept. We talked about how when we have a y-intercept, such as the one shown over here, when we have a y-intercept, since we do not move left or right at all, since we are right on the y-axis, it is an x value of 0. So whenever we find our x-intercept, or excuse me, our y-intercept, we do that by plugging in x equals 0. It's kind of a crazy looking 0. The one thing we have not talked about yet is our x-intercepts. I alluded to the fact that we would be moving into that. We have not yet. So if we look at what it means to be an x-intercept, notice here I've drawn an example of a linear equation. I know it's linear because it is just that straight line. We have talked already about how to find x-intercepts for a linear equation, and we talked about how whenever we have a linear equation, if we are looking at that x-intercept, we are able to say that, okay, our x-intercept does not go up or down, it's right on the x-axis, therefore we can always say that y equals 0. Well, I've also drawn two separate examples here of a quadratic equation. Notice that with a quadratic equation we do get that parabola, and notice that we have our x-intercepts both here and here, and notice that on each of our x-intercepts, similar to the linear equation, we don't move up or down at all. We are right on that x-axis. Therefore, once again, we can say my y value for each of these points is 0. It also works for this parabola, this quadratic equation here. Again, I have an x-intercept here, and I also have an x-intercept here, and both of these have moved up or down nothing, so it is a y value of 0. So using that same idea, or that same concept that we used when we worked with linear equations, in order to solve for an x-intercept, we are going to look, when does y equals 0, what x value do I get? So what does it mean to solve a quadratic equation? Well, it means this. Up until now, these are the types of equations we have looked at. If I look at this one here, we've dealt with quadratic equations like this. We've taken an equation like this, and we've been able to determine what its shape is, what its axis of symmetry, its vertex, its y-intercept is. We've also learned how to factor it. Now we're going to take it a step further and say, what if I want to find the x-intercept? What do I need to do to my current form of my equation to solve for the x-intercept? Well, all I need to do is change it into this form here. Notice all I've done is taken my y value, and I've plugged in a 0 where the y is. This is going to be now now written in standard form, where I can solve my quadratic equation or find my x-intercept. If I look at this equation that I have here, notice it is very similar to the first two equations. The difference being, of course, is now that it is not in standard form. Remember, standard form does mean my exponents are in descending order, and my exponents are not in descending order. My linear term is on the wrong side of the equation. So notice that I am able to bring that over to the other side by simply adding a 6x to each side of the equation. Here my 6x's cancel, giving me that 0. Remember, because of our commutative property. I am able to add the 6x anywhere along in here. I can put it wherever I want. I cannot combine it with the x squared because they are not like terms. Similarly, I cannot combine it with the 8. Again, not like terms. They do not all have the same variable part. So adding the 6x in, I come up with x squared plus 6x plus 8 equals 0. I am now in standard form, and notice that by putting it in standard form, it has automatically plugged a 0 in for y for me. So when I go to solve this, I am in fact solving for my x-intercept, again, because 0 is automatically in the spot where y would be in my standard form. We will learn many different methods on how to solve quadratic equations, as you can see up here. The first one we will learn is how to solve by taking square roots. Before I get into examples of solving by taking square roots, I would like to go over all the different methods. We are going to learn a brief overview of them. So, as you can see on the slide here, here are all the ways we are going to learn how to solve quadratic equations. We will start by learning how to solve by taking square roots. Once we have mastered that concept, we're going to move into solving by factoring. Then we will learn how to solve by using the quadratic formula, which I will give you. And then there's going to be this piece over here, solving by completing the square. This will be an extension piece, so you will not be required to learn it. But as you're moving through this, if you do master these concepts faster than others in the class, I will ask you to go ahead and view a video on solving by completing the square. What I will have you do now is if you go back onto the Moodle website, you will see that there is another video on there for solving quadratic equations by taking square roots. If you now click on that video, it's going to walk you through some examples of when we solve by taking square roots and what that looks like.